So let us see that we can have to discuss about the properties of the nth roots. So what are the nth roots? These are the expressions with different roots. Can be the square root, cube root, and can be, let's say, fourth root, 15th root, and whichever the root, but just have to get it up to that. We have to discuss about the properties of nth roots. So now the principle behind the properties of nth roots is to look at how can be able to work out with the actually roots, and as far as the algebra is concerned, how can be able to multiply, divide, or even the addition of the actually expressions with different roots. So that's the principle behind the properties of the nth roots. So the following are the properties you have to understand and how you can be able to work out with the actually nth roots expressions. Now we have the first property, which is given as, now if we have the nth root of x to the power n, and of which this can also be given as, let's say, the nth root of x to the power over to the power n. Now this is the same as having it as x. So now the principle behind it says that the value of the root, now the principle behind it says that if the value of the root is the same power for x, that means we'll have it as the value of x, in the sense that you should have to depict it from the principle behind the laws of indices, that which says that having, let's say, the nth root of x to the power n, this is the same as having it as x to the power n in the overall terms 1 over n. In this case, this is the same as x to the power n over n. We have to cancel this to have it as x. That's the principle behind. And in this case, you can also have it in this case, which means, let's say, if we have, let's say, the square root of, let's say, 2, now should be the square root of, let's say, 2 to the power 2. This is the same as 2. Let's say the cube root of x to the power 3. This is the same as 3. Let's say the fourth root of, let's say, m to the power, let's say, 4. This is the same as actually m. Much as the power and the square is the same. That's the principle behind that property. And we also have another nth root property, which is that of, let's say, if we have the nth root of x times y. So now, since we have the two actually variables that are multiplying, or the two expressions that are multiplying inside the nth root, and this is the same as having it as the nth root of x and the times the nth root of actually a y. That's the principle behind. And what is the practical example on that property? So now let's say if we have, let's say, the fourth root of 5, and we have times the fourth root of, let's say, a 6. Now this is the same as the fourth root of 5 times 6, which is the same as the fourth root of should be 30. And this is happening because the value of the root is the same. So keep that in mind. And likewise, if we have, let's say, the nth root of x over y, according to the principle behind the laws of indices, and this is the same as having it as nth root of x divided by the nth root of should be that of y. So which means, let's say, if we have, let's say, cube root of 5 divided by, let's say, 6, and this is the same as the cube root of 5 divided by the cube root of 6. That's the practical working example on how you can be able to demonstrate that property. And I also have this case where, let's say, if we have the nth root of, let's say, x to the power n. Now, provided that the power is actually a positive, should be provided the power is an even number, then the result will be the positive actual x, in the sense that, let's say, if we have, let's say, the square of negative 2 to the power, let's say, a 6. So now, since the power is negative, actually, since the power is the even number, what I'm going to have will be the positive value. That is because this is the same as having as, no, should be like this. Let's say should be the 16th root of, now should be the 16th root of negative 2 to the power 6. Now this is the same as having it as the positive value of 2. So have the positive value of 2, that will be given as 2, since the power is the even number. Actually, in other ways, if it happens that the root is of the positive actually a natural number, then it means actually if it happens that the root is of the positive actually power, now should be if it happens that the root is of the even number, that is 6, then what you're going to have from here will be the positive value. That is, you see there's some of the typical practical examples to do that one, but just have to know the way that one should be having up to. Let me also have to specify, let's say if we have, let's say the 4th root of, let me just have it this way. Let's just have the square root of, let's just have it as, let's say, negative, let's say 2 to the power 2. And of course this is the same as the square root of, now should be a square root of 4. That is because we have negative 2 times negative 2. And this is the same as having it as the square root of 2 to the power 2. That will be given as 2. That's the practical working example now on how can be able to demonstrate that one up to. Let's say if we have, let's say, the 4th root of, let's say, x, actually negative x, to the power actually 4. Now since the power is positive, actually since the power is even number, now this is the same as the 4th root of, now we should have it as the negative x, and then times negative x, and times negative x times negative x. That's what will happen. And this corresponds to have it as the 4th root of x to the power should be that of 4. Now in this case, this is the same as having it as x. You can see that what they're having out is the positive number. So that is only happens if the power is the even number corresponding to the nature of the root. So keep that in mind. Now what if we have it as the odd number? Let's say we have the nth root of x to the power n given as the n, given that the n is the odd number. You see that we may end up having any kind of the x value in that case, which means can be negative or positive. Let's try to go through this. Let's say we have the cube root of negative, let's say a 2 to the power, let's say 3. Now this is the same as having it as, now the cube root of negative 2 times negative 2 times negative 2 should be times negative 2. And of which you see that we'll have it as the cube root of, now should be the cube root of negative, now should be a negative 8, and to the power 2 should be, we'll have it as negative 2 to the power 3, and of which this 3 and this 3 will have to go, what we'll have is a negative 2. That is the only happen if the power is odd number. So you see some of the practical examples to do with that one, but just have to give that an up to. And now what if we also have this case? We should have to understand about the other property, which is that of, if we have, let's say, nth root of the, let's say, mth root of, that should be x. Now this is the same as having it as, should be the mnth root of x. What is the practical way out up to this far? Using the laws of indices, you have to understand about this one. Having the way this one is, this is the same as having it as x to the power, let's say, 1 over m, and the overall to the power 1 over n, and of which, using the power distribution law, we'll have it as x to the power 1 over mn. So you can see that the power is the actually the power is the fraction number. So in that case, it means the denominator will be the root. In this case, we'll have it as the mnth root of x, and the overall to the power 1, of which you just have to simply have it as this, because the power 1 is the same as the same. So the power 1 does not change anything. So which means having this one, it corresponds to half that and as that according to the laws of indices. So now keep that in mind. So let us see that we can have to apply the concept of the properties of the nth roots, and are some typical problems to have to understand up to. But before we go further in that case, you have to understand about this. You should have to understand about the perfect square. What is a perfect square? Now a perfect square, this is the number formed upon having the same number multiplying itself about 2 times. So which means we can have 2 times 2, which is 4. 4 is a perfect square. We have 9, have 16, 25, 36, and there are many of them. And I should also have to understand about the perfect cubic factor. Now this is the number formed upon having the same number multiplied itself about 3 times. So which means 2 times 2 times 2, that is 8. This is the perfect cubic factor, which corresponds to 2 to the power 3. And we can have 3 times 3 times 3, which is given as 27. That corresponds to 3 to the power 3. This is the perfect cubic factor. And we can also have the perfect, should be the perfect, that is the perfect fourth factor. This is the number multiplying itself. This is the number formed upon having a number multiplying itself about 4 times. And we can also have the perfect 15th factor, and also up to whatever we think about, but just have to know that. Now let's have to simplify the following. Let's say if we have the square root of 12 plus the square root of, let's say, 75. So now since the roots that we are having is that of the square root, it means we'll have to think of the perfect squares. So actually, by the way, another name for roots is said to be the radicals. So the radicals of interest are that of the square roots. So which means we'll have to think about the perfect squares for us to simplify the expression that we have. So how should we be able to simplify this? Think of 12 as well as the 75. So we should have to come up with the pair of factors of, should be the pair of the factors of 12, and that contains a perfect square. So which means we'll have 4 times 3. This is the pair of the factors of 12, and that contains one of the factors as the perfect square. And how about 75? So on the 75 we have 25 times 3. So which means we can be able to break those values into those cases. So in this case we'll have it as the square of 4 times 3, and the plus the square of 25 times 3. That's what it means. Of course, this is the same as having it as the square of 4 times the square of 3, plus the square of 25 times the square of 3, and of which this is the same as 2 times the square of 3, and plus 5 times the square of 3. This is the same as having it as the 7 times the square of 3. That is the way out in that case. So if you have the square root, think of the perfect square. If you have the cube root, think of the perfect cubic factor. That is, let's say if we have a square of 162 divided by, let's say, 49. And of course this is the same as having it as the square of 162 divided by the square of 49. Now, do we have the direct value for the square of 162? 162 is not the perfect square, but we have the square of 47, which is given us, and that should be that of, we have the square of 49, which is given us, that of the 7. So we have over 7 here. How should we be able to work out on the 162? So now we have a pair of the factors of 162 that contains the perfect square. We have it as 162 is the same as 81 times that of 2. That is the same as that. So which means we can have it as now the square root of 81 times the square root of 2 divided by 7, which is the same as, what is the square root of 89? We'll have it as the 9 times the square root of 2 divided by 7. So that is the solution. Now about if we have this case. Let's say we have a cube root of 16 and plus, let's say the cube root of, let's say 250 and the minus the cube root of should be 128. So now since we are having the roots of constant, that is the cube roots, which means we should have to think about the cubic perfect factors. So what is the pair of the factors? By the way, do we have the direct a value for the cube root of 16? We do not have, because 16 is not that of the perfect cubic factor. In that of 250, actually it is not the perfect cubic factor, and also 128 it is not the perfect cubic factor. So now, if you are saying 16 is not the perfect, actually it's not a perfect cubic factor, is that we mean we cannot be able to express 16 to have the power of 3 as it is, and even that of 250 can be expressed to have the power of 3, and also 128 can be expressed to have the power of 3. That's the principle behind a perfect cubic factor. But let's think of the pair of the factor of 16 that will contain the perfect cubic factor. So have it as 8 times 2. And what about on 250? On 250 we can have 125 times 2. How about on 128? We'll have a 64 times 2. That will work. So now which means that is how we can be able to have it up to. So have the cube root of 8 times 2 plus the cube root of, now that is cube root of 125 times 2 minus the cube root of 64 times 2. So what is the cube root of 8? That is, how should you have to express 8 to have power 3? So you see that we'll have it as 2 times the cube root of 2. And we'll have, what is this? We'll have it as 5 times the cube root of 2. Minus, what is this? We'll have it as 4 times the cube root of 2. So now these are the right terms you can be able to work out them in that case. So bear that in mind. What if we have these cases? Let's say if we can have, that should be, let's say, a cube root of, let's say 16y to the power 5. So how should we have to express 16 to have the actually perfect cubic factor? And how about the y to the power, let's say, a 5? So you see that having this is the same as having it as the cube root of 8 times 2 times y to the power, let's say, a 3, and times y to the power 2. So now in this case, this is the same as having it as, what is the cube root of 8? Or have it as 2. What is the cube root of y to the power 3? Or have it as y in the terms, now the cube root of 2 times y to the power 2. That is the working principle in that case. Now about if we have, let's say this case, we have, now should be the square root of 8 times x squared. So now 8 is not perfect square. Since we are having the square root, it means we have to go for the perfect squares. So now this is the same as 4 times 2 times x squared. That corresponds to have it as 2 times the square root of now 2x, because what is the square root of x squared is the same as x times the square root of 2. That is the working principle behind that. And say, what if we have the following cases which you have to understand as well up to. Let's say if we have the fourth root of, let's say, 32 a to the power 6 times b to the power 5 and over divided by, let's say, c to the power 8. The solution over this, and of course, having this, now we are having the fourth root, so which means our point of interest will be having the perfect, now should be a perfect actually fourth factor. That is the number formed upon having the said number multiply itself about 4 times. Should be upon having the number multiplying itself about 4 times. So which means, now before we go further, this is the same as having it as fourth root of 32 times a to the power 6 times b to the power 5 divided by the fourth root of c to the power 8. Now let's think of breaking the values that we have. And now this is the same as fourth root of, that should be 16 times 2, much as we have 2 to the power 4, that is given as 16. So which means 16 is a part of the perfect fourth factor. In the times, how can we have 8 to the power 6 having the perfect fourth factor? We have 8 to the power 4 times 8 to the power 2. How about this one? We'll have it as, should be b to the power 4 times just have b, then divide by, and how about this one? That is the same as the fourth root of c to the power, let's say, 4 times c to the power, should be given that of a 4. And of course, that's the working principle. The next from there, we'll have this. Which means we can have to work it as, what is a fourth root of 16? We'll have it as 2. What is fourth root of 8 to the power 4? We have it as a. And b to the power 4, we'll have it as b times 2 fourth root of 2 times a squared times b. So that is the solution on the denominator. Divide by, what is the fourth root of 8 to the power 4? We have it as a c times, what is the fourth root of c to the power 4? We have it as c as well. So which means we'll have it as 2ab, now fourth root of actually 2 times a squared times b, and that of divided by c squared. So that's the solution over that. So keep that in mind. And what if, let's say, we have this case? Let's say if we can have how can we be able to work out this? Let's say have the score of 150. So how should you have to simplify this? Now we do not have the direct value for the score of 150 because 150 is not the perfect square. Now, but let's think of the pair of its factors. In this case, this is the same as the square of what? Should be a square of, so which means we'll have it as 25 times 6. So where 25 is the perfect square. So try to complete that one up to at your own time. Now let's think about this as well. What if we have, let's say, the cube root of, let's say, 375? How should we have the solution for this one? So since this is the cube root, we should have to think of the perfect cubic factor. Now, is actually 375 a part of the perfect cubic factor? Now, in other words, can you be able to express 375 to have the power of, actually to have the power of 3? And how can we have that one up to? So another way you can have to try that one is to go by this, where you have 375. So what is the possible, actually a common factor? Should be, we'll have it as 5. What is 5 into 375? We'll have it as, so we'll have, should be now a 5, 375 in that way. So 5 into 1, actually 35, actually into 37, we'll have it as a 7. And that times 35, we'll have times 35, actually minus 35, that will be given as 2, should be that, and that 2, and the 5 into 25, we'll have it as 5. So which means, now should be, which means we'll have 5 into 25, should be this. So which means we'll have 25. The minus, we'll have it as 0. So this is 75. So how about 5 into 75? We also have to last it in the same way. We should have to see if it is possible to have 375 to have the power of 3. Let's also last it in the same way. We'll have, so 575. What is that? We have 1, which means we're going to have it as, it should be 5. We have it as 2. We'll have it as 5. So which means we'll have 25. So 5 into this one, of course it should be given as 5 rather. What's going on there? We'll have it as 5. So which means if 5 into 25, it should be given as 5. And 5 like that. So which means 375 is not the part of the perfect cubic factor. So which means we should have to think of expressing, actually expressing 375 to have the pair of the factors that consist with the perfect cubic factor. So take note of that. Now which means we'll have it as 125 times 5. So that is the pair of interest. So now which means we'll have it as, now the cube root of 125 times 5, that which is the same as the cube root of, so what is the cube root of 125? We'll have it as a 5. So which means we just have to simply have it as a 5 times the cube root of 5. That's the working principle behind that. Now what if we have, let's say, this case? Let's say we have, that should be, let's say we have the cube root of, let's say, negative 108. Now how should we be able to go over this problem if this is the case? So now simply we also have to last in the same way. So now since we have the active cube root, it means we'll have to think of the perfect cubic factor. So is 108 is a perfect cubic factor? We're not so sure, but let's have to try to see if it is. But we cannot be able to express 105 to have the power of 3. But rather we should have to think of the factors we should have to express up to. What are those? But now we should have to do this in order to deduce the factors. This is the only simplest way to go through when it comes to those cases. Let's have 108 in this way. What is the lowest possible common factor? We'll have it as a 2. Now what is 2 into 108? We'll have it as a 50, should be 54. What is 2 into that? What is a 2 into 54? We'll have it as, now should be given as 27. So we have 3 into 27. We'll have it as a 9. We'll have it as that, which is given as that. So which means 108 can be expressed as having it as 4 times. Now should be a 27. So since we can have it as 4 times 3 to the power 3. So that's the working principle. So which means the pair of interest will be that of the cube root of minus 27. So this negative has to be a part of the perfect cubic factor in the terms actually 4. So what is the cube root of negative 127? We'll have actually negative 27. So now we'll have it as a negative 3 times the cube root of 4. That is the solution. So keep that in mind. And also let's try to finally go through this and appreciate as well. Now what if we have, let's say, this case. Let's say we have the 15th root of, let's say, negative 2 and the plus the 15th root of, let's say, negative 64 and the minus the 15th root of, let's say, 486. So how should you have these up to? So now obviously we're going to be able to express that of actually 15th root of negative 2. It is impossible. So which means we'll just have to write it in that way. But let's go for this one. Can we be able to have the 15th root of negative 64? No, because 64 is not part of a perfect 15th factor. So the best way is to express if it can have it up to that one. So let's have this, if we can have the pair of the factors. So have 64, have 2. What is 2 into 64? So which means we'll have it as 32. And at 2 like that, we'll have it as the 16. And that 2 into that, we'll have it as 8. We'll have it as 4, 2. Now should be that. So I have 1, 2, 3, 4, 5, 6. But the interest is to have the power of 5. So which means we'll have 2 to the power of 5 times 2. Which means this expression can be expressed in this way. So that's the working principle behind that. So now which means we'll have it as this case. Actually a 15th root of negative 2. Now should be this. Now should be the 15th root of negative, actually 15th root of 5 times negative 2 and the plus. Now the 15th root of, now should be the 2 to the power 5 like that, and of course we'll have times negative 2. Now since here we have the negative 2 in the 15th root, it means we also have to consider negative to be part of the 2. And the minus, also try to go through that one the way we have done it here. So try to proceed that one at your own time. in case you may wish to, but you have to wish to. Now try these at your own time in that way. Let's say we have the following cases. Let's say if we have a 4 times the square root of 24 minus 8 times the square root of, let's say, 54, and that plus, let's say, 2 times the square root of 6. And also try this. Let's say if we have a times b squared times, let's say, 8 to the power 3 times b. And what if we have this? Let's say we have the cube root of, let's say, 16 a to the power, let's say, 12 divided by, that should be times b squared, and that divided by c to the power 9 in the same cube root. You also try this at your own time. We wish to have this as, let's say, we have the square root of a plus b over the power 5, and that divided by, let's say, 16 a to the power 5, that should be to the power 2 rather, in times b square also. So try to simplify this at your own time. So try to go through more examples that are more practical questions, and I should have to be mastermind these things. So thank you.